Imagine watching a fully loaded cargo ship glide calmly, and then begin to climb straight up a mountain. No special effects, no science fiction. This is not a fantasy or a futuristic concept. It's happening right now. And to witness it with your own eyes, there's only one place on Earth where this is possible: China. In the modern world, feats like this exist thanks to one crucial force: hydroelectric power and megadams. And no country has mastered this domain like China. Today, nearly one-third of all installed hydroelectric capacity on the planet belongs to the country, a staggering figure that reflects decades of relentless engineering ambition. China is home to countless hydroelectric plants, many of which hold global records. Among them is the Baihitan Dam, one of the largest hydroelectric power stations ever built. With an installed capacity reaching 1 million kilowatts, its scale is monumental and its annual energy generation is extraordinary. Although its capacity is slightly smaller than that of the Three Gorges Dam, it still ranks as the second-largest hydroelectric power plant in the world. In fact, the 5 largest hydroelectric power plants on Earth are all Chinese projects. But power generation is only part of the story. In China, engineers have accomplished something even more astonishing. They've made ships sail over mountains. In today's video, you'll discover how this seemingly impossible feat became reality through the use of massive ship lifts, turning science fiction into everyday infrastructure. But before we begin, don't forget to like the video and subscribe to our channel. This is the Gupatan Hydropower Station, where the dam rises 763 feet tall, and the total vertical drop conquered by the ship lift reaches an astonishing 653 feet, the height of a 66-story building. Ships are raised in 3 vertical stages to bypass the dam, traveling directly from the lower stretch to the upper stretch of the Wujiang River, making it one of the largest ship lifts in the world. But how does this system actually work? First, a 500-ton vessel enters a gigantic transport chamber measuring 131 feet long and 39 feet wide. The chamber is then flooded with water, effectively transforming it into a movable canal. Pulled by 256 steel cables, the chamber is raised or lowered vertically through a rack and pinion system, with each stage taking about 30 minutes. To complete the journey, the ship must ascend 3 lift levels, totaling roughly 2.5 hours, cutting travel time by 4 full days compared to traditional winding mountain routes. For the first time in the world, the system uses a rack and nut column safety mechanism capable of withstanding level 8 earthquakes, extreme winds, and powerful waves. Precision is maintained within a margin of plus or minus 0.4 inches, allowing vessels of up to 1,000 tons to cross the mountain smoothly and safely. This project restored full navigation along the Wujiang River, opening the so-called Golden Waterway that links Guizhou to the Yangtze River, increasing annual cargo capacity to 5 million tons and accelerating the development of the central Guizhou economic zone. The International Navigation Association even described it as a redefinition of what is possible in inland navigation. Now, watch closely as a ship follows the canal, approaches a towering structure, and disappears inside, beginning its climb over the mountain. Inside this structure, a lifting cable hangs suspended, flanked by 2 rows of drums and gearboxes on each side. For residents of an ordinary multi-story building, an elevator of this kind might seem both astonishing and slow, given the enormous internal space it occupies. However, the designers claim that this ship lift can raise or lower a 500-ton vessel in about 10 minutes. In other words, a standard passenger ship can leave its original position with ease in such a short time. The gigantic lift has a maximum load capacity of 18,800 tons. Although a vessel may take slightly longer to be fully raised, this hardly matters, since any watercraft will be lifted to an impressive height of 236 feet. It is worth noting that this height can vary depending on downstream water levels, with a maximum vertical difference that can reach 656 feet. Some have even called the elevator system of the Gupatan Dam an incredible feat of engineering. Of course, this praise can be debated. since ship lifts have existed in various parts of the world for quite some time. However, you'll soon realize that this system does not consist of a single lift. In fact, it is made up of three. After the first lift, there is a second one that raises vessels to a height of 427 feet. Its operating principle is simple. The ship enters, waits for the system to activate, and is then lifted as a whole. Through the Gupudon Dam lifting system, the water level of the entire navigation channel is raised by up to 653 feet. Simply unbelievable. To put this into perspective, the height to which a ship is lifted is equivalent to a 66-story building. If you were standing near the Great Pyramid of Giza, you would see that it is 456 feet tall, while the Statue of Liberty in the United States stands at just 305 feet. This makes the ingenuity of Chinese engineers even more admirable, since a vertical difference of 653 feet is almost unimaginable. Under normal conditions, a river with such a dramatic drop in elevation would be impossible to navigate. However, through advanced engineering techniques, the Chinese achieved this remarkable feat, earning them the nickname infrastructure maniacs. Moving on, after a ship passes through two lifts, it still needs to be lowered somehow to reach the water level behind the dam. To accomplish this, the system includes an additional lift at the end of the mountainous route, with a maximum descent height of up to 154 feet, again depending on water levels. In terms of throughput capacity, this system may seem relatively limited, even though the ship is lifted quickly. It can only transport one vessel at a time, which means the overall capacity of the lift system is not very high. In fact, this can even lead to waiting lines. However, as soon as a ship passes through the first lift, the next one can already begin its ascent. While this arrangement is not perfect, the project engineers did everything possible to speed up the transport along this unique route, which consists of 3 lifts and a stretch of water channel. The system makes changes in elevation extremely simple and undoubtedly represents yet another impressive achievement of Chinese engineering. There is still a certain distance between the lifts that must be traveled, but in this case, that does not pose a major challenge. Traditionally, locks are used to transfer vessels between different levels without the need to cross mountains. Multi-stage changes in elevation are usually achieved with several locks that slowly raise or lower a ship, step by step. Here, however, vessels must navigate between mountains. Initially, there was no river beneath the lift system, so in addition to building the 3 lifts, another feat was required, creating a connecting canal between them. In the end, the main stretch between the 2 lifts and the mountain is an open water channel. This does not mean that building such a canal is unusual. Engineers in ancient times accomplished similar feats without modern technology. However, in this case, integrating the canal system with rugged, mountainous terrain, along with the entire lift system, greatly increased the complexity. Even so, Chinese engineers successfully overcame these challenges, completing a second mountain crossing route. In fact, one doesn't even need to ask how China managed to do it. The country has accumulated vast experience in tunnel construction, using massive tunnel-boring machines to excavate passages and ensure everything was completed according to plan. As a result, a mountain route stretching 1.4 miles was created. The entire project cost an astonishing $7.75 billion, and it is precisely thanks to this ship lift system that vessels are able to cross the most dangerous terrain in the region. If a traditional lock system had been used, each ship would have faced far greater difficulties along the route. You may have already noticed that the water channel at the lift system were built specifically because the Gupudon Dam is located in this region. This ship lift is one of the dam's most essential support facilities. In summary, the Gupudon Dam and its hydroelectric plant are not, by themselves, particularly extraordinary. The only truly unique aspect is its advantageous navigation system, which allows ships to literally fly over mountain ranges. This raises another question. Why did China need to make such a massive investment, consuming enormous amounts of effort, time, and capital, to build this system, especially when the project itself does not appear so grand? First, let's look at the location of the dam and the navigation system. For vessels, this area is narrow and environmentally hostile, to the point that using a traditional lock system would be unfeasible. It is worth noting that after the completion of the Gupudan Dam, Chinese engineers carried out significant work across the entire complex. Building any dam creates a barrier in the river, causing water to accumulate on one side and raising the level on the other. Although in some places this difference in elevation is not very noticeable, in the case of the Gupudan hydropower station, the height difference is so great that the designers had to abandon the idea of a single ship lift. Raising vessels in that way would not only be time-consuming, but also extremely dangerous. For this reason, building the dam and the hydropower plant in this context became essential, despite requiring colossal effort and extremely high costs. Thus, in order to develop new energy sources in the region, while simultaneously establishing a waterborne transportation network, Guizhou built the Gupudan hydropower station and its shiplift system, which has an annual cargo capacity of 2.908 billion tons. Some may argue that using trucks or rail freight cars would also be feasible, but these methods are far less efficient. A standard truck carries about 25 tons, whereas the Gupudan lift can hoist a 500-ton vessel, and that is not even its maximum limit. In practice, a single barge can replace dozens of trucks. Considering road construction in the mountainous areas of Guizhou, it is nearly impossible to build wide highways suitable for large volumes of small trucks and tourist vehicles. Allowing trucks to travel on narrow mountain roads and bridges poses significant risks. Since waterborne transport exists and barges and cargo ships are far more fuel efficient, rail transport, although somewhat better than trucking, also faces its own challenges, such as the difficulty of laying tracks and lower overall efficiency compared with river transport. Despite all the challenges associated with the shiplift system, this region arrived at the optimal solution through massive investment. As a result, we can witness such a spectacular scene and truly understand how real the idea of ships traveling through mountains actually is. After all, a shiplift capable of hoisting 10,000 tons is, by itself, an astonishing feat of engineering. The completion of this project caused a strong reaction among internet users overseas. Many commented that the ship lift alone is jaw-dropping. This navigation channel built atop the massive structure of the Gupudan hydropower station is a true world-class aquatic viaduct. With design and construction quality that is simply mind-blowing and a water tunnel cutting through the mountains, this is pure genius. China is able to build infrastructure of this level for less than half the cost of a single Arleigh Burke-class destroyer, while simultaneously maintaining navigation on a major river. What an incredible deal! Others added that projects like this seem almost routine for China, yet they remain marvels of engineering. If this were in the United States, it would take about 50 years to plan and another 50 years to build, if it were ever completed at all. While some of these comments are exaggerated, they undoubtedly reflect the impressive capabilities of modern Chinese engineering. Now let's take a look at the ship lift of the Three Gorges Dam in China. This system is capable of lifting ships weighing up to 3,000 tons, completing a full cycle in just 40 minutes, figures that are impressive in their own right. As the saying goes, with great power comes great size. The lift chamber measures 400 feet in length and 60 feet in width, holding a volume of water equivalent to 4 Olympic swimming pools. Its colossal scale allows it to accommodate virtually any vessel within its maximum capacity. Imagine lifting a ship of such immense weight to a height of 371 feet above the ground. It is almost unbelievable. Even so, it must be emphasized that raising such a massive load to such an elevation in a single movement is, in itself, an extraordinary achievement, and the brilliance of Chinese engineers cannot be overlooked. They also devoted great attention to safety. 4 sets of drive mechanisms were installed symmetrically, equipped with gears and supports that firmly reinforce all 4 corners of the ship cabin. This configuration effectively eliminates the negative effects caused by tilting or water movement inside the chamber and drastically reduces the risk of capsizing. The designers also ensured that even in emergency situations, such as earthquakes, the system remains safe, as the lift cabin is equipped with damping devices capable of absorbing vibrations and impacts. A construction expert involved in the project highlighted the seismic protection system, which dissipates earthquake forces through multiple support pillars, preventing chamber collapse and other catastrophic failures. Since the multi-stage lock system of the Three Gorges Dam went into operation, its benefits have already begun to appear. According to media reports, the volume of cargo transported through the dam reached 100 million tons in the first half of 2024, an increase of 10.32% compared to the same period the previous year, setting a new historical record for the Three Gorges locks. As expected, before the ship lift came into operation, vessels still had to bypass the dam through another engineering marvel, the 5-stage lock system. Installed alongside the dam are 2 parallel lock complexes, each composed of 5 chambers, with a total transit time of approximately 4 hours. This difference, 40 minutes versus 4 hours, is precisely why China is prioritizing the construction of a new lock system. Delays of this magnitude can severely impact individual companies and even the Chinese economy as a whole. Considering that the Yangtze River is a crucial maritime artery with no viable alternatives, the impact of these locks is enormous. Even with a 4-hour transit time per vessel, the dam's annual cargo volume reached 180 million tons in 2024, and this number continues to grow alongside China's economic expansion. Interestingly, initial projections estimated a maximum annual capacity of only 100 million tons, a figure that was clearly underestimated. With each mega-project completed, China continues to overcome world-class engineering challenges through innovative techniques and advanced construction methods, further solidifying its nickname as the infrastructure maniac. Moreover, China has carried out major projects in numerous other countries, each representing its drive for development. Behind China's global leadership in infrastructure lies not only a technological leap, but also the support of a powerful nation. Over more than a century, from the devastation at the founding of the People's Republic of China, it has been the successive struggles of generations of Chinese engineers that have built the image of today's prosperous China. And still, this is not the end. In the future, the infrastructure maniac will continue helping more developing countries modernize, creating new opportunities for growth and building a better, more livable world for everyone. Every bridge, every road, and every project connects cities and rural areas, the present and the future, China and the world. Chinese infrastructure has not only reshaped the face of China, but has also exemplified the nation's strength, spirit, and speed. The infrastructure maniac will never stop. What miracles do you think Chinese infrastructure will create over the next decade? Share your thoughts in the comments and don't forget to subscribe and activate the bell. See you in the next video.